Before to go ahead, I'd like to introduce myself. My name is Icaro, and I work to a company based in Montreal, actually a startup. We develop network solutions, actually software-defined solutions, and we work basically with Opendaylight. That's a network framework that is trying to be the standard in this networks environment. And my GitHub is there, my Twitter is there, so let's go. The internet is made up of tens of millions of servers, routers, and switches. And in the epoch, it was designed to work with IPv4. And in 2003, we had in the world 6.3 billion of people and 500 million of connected devices. And around 2008 and 2009, we had more connected devices than people. So, as you can see, the prediction to 2020, it's about to have 7.6 billion people and 50 billion connected devices. So I have a question to you guys, and I know you are smart enough. Where's the network we have today designed to our actual demand? It's an easy question to answer. So the current networks don't have the ability to provision network service in the way that we need today, quickly and easily. And I'm pretty sure you have heard about the IPv4 address exhaustion, and I'd like to talk about it because I'd like to give you a little bit of context about how networks are difficult to change, to innovate. So we had this problem in 1995. IPv4 address were not available. I mean, we had this problem, the exhaustion. And we tried to solve this problem differently and using some workarounds and band-aid solutions like NET. Are you guys familiar with NET? Network Address Translation? And it's cool, it works, but just in a certain point. So what about IPv6? Because IPv4, we have 32 bits, and IPv6, we have 128 bits. So we have more space, we'll have more address. But the point is, it's hard to turn off our network and turn off our network and infrastructure and change IPv4 for IPv6. And the reasons for the gradual adoption are simple to understand. It's expensive as well. So take a look at this picture. So it's basically a data center topology. And we have here core and the aggregation suites in the top of rack. So imagine a data center like Google, Amazon, or Windows Azure. And we need to change, and you need to make some configuration. And as we are using in these days, we've been using a lot of VMs and a lot of machines and a lot of computers and a lot of stuff that requires that our network, it needs to be more flexible to be able to provide this kind of service. So before to go ahead, we still have a different problem here. So can you see these suites here, the green rectangle are suites, and imagine if that you have a network device that were built by HP or Cisco or different vendors, and we want to make to provision your network and your infrastructure to be more flexible. So just an example here. If you take a look at this top of rack stuff, and if you'd like to change it, we have here HP and Cisco and I don't know, Nicira stuff, and they talk its own language. It's difficult to change because, for example, Cisco use iOS, I guess, and HP use its own language, and Nicira as well. So we'll have this kind of vendor locking problem, and it's not what we want, and it's hard to maintain a topology and an infrastructure like this. So how to innovate in this scenario? Because we need actually rapid provision of network service in data center, as I've mentioned before. And you also need reduced operational costs. So if you take a look at the picture that I showed you, it's feasible, it's doable. We can change, but it's a pain. It's hard. And the operational costs are high. So we have SDN. Actually, it's a network architecture. And it's a way to go. It's one option to start building a more open and dynamic network. How many of you have heard about SDN, software-defined networks? Oh, nice. I wasn't expecting for it. That's cool. So, how many of you have heard about OpenFlow protocol? Okay. Okay, so OpenFlow protocol was the first protocol that was designed to implement software-defined networks. Actually, we had some other protocols before, but OpenFlow was a mark, was developed in Stanford around 2009 and 10, and the first version was deployed in 2011. So why OpenFlow is important? Because actually it decouples our switch. Actually, it works with switch in a control plane and forward or data plane. So just to give you an example, in OpenFlow we have a switch. Here's a switch, and we have now with OpenFlow, the route, the intelligence of the network is controlled by an entity that's called controller. So, and the hardware itself, the switch itself, just forwards package. So I have, using OpenFlow, I have all my networks mapped, and I have all the controller, all the topology of the network controlled by this guy controller. So OpenFlow, these are two simple examples of the OpenFlow protocol. Actually, we are seeing here the headers, an OpenFlow header. So some people don't like it, OpenFlow, because network purists, they like to have very separated layers in the network, layer 2, layer 3, layer 4, and so on. And in OpenFlow, we have kind of a mix. As you can see here, switch, MAC, Ethernet type, VLAN, IP source, destination, IP protocol, TCP. So we have layer 2 and 3, and mixed, and we have also an action. So for example, imagine we have a switch in our topology, and I'd like to enable just a simple switch function. So I use the MAC destination 001F, and I write an action to port C. What does it mean? It means when a flow enters in the switch, a match will be happen, and if that flows come to the destination, the MAC destination 001F, that action is going to be applied. So the flows comes in and matches with a role that I wrote, and an action. Actually, here it's an output action that is going to forward the flow to the port number 6. And for example, here I have a firewall. Just a quick example here, very straightforward. Here I'm blocking all the flows, all the network packets that goes to the port 22, and I have an action that's called drop. What does it mean? It means when the switch identifies that a flow is coming and needs to go to the port 22, this flow is going to be dropped. So it works like a firewall. And it's all programmable. That's nice. that's simple, and we just need to understand a little bit about the OpenFlow protocol. But we have APIs, we have ways to deal with this network stuff. So as I mentioned before, the OpenFlow protocol decouples the control plane and the forward data plane. So the control plane, it's the logic for controlling the forward behavior. So instead of have a switch that controls the route, and we have the route and forwards the package, we also have now we have a controller that's responsible to deal with the logic. So for example, in a topology, I have different paths to send my flows, to send my package. And controller now, this entity is now responsible for this decision. Not the switch anymore, sorry. And the forward plane, it's just the work that the switch is going to keep doing. That's just forward package. So we have here a simple topology, and we have an SDN topology here. Actually, the topology is common, but with SDN strategy, we have there controller. So as you can see, we have lines that are tied to the controller because he knows every single node in the network. It needs to be to calculate the routes, and to calculate the routes, we use the basic protocols. And we have virtual suites here. We are using most of times we use Open vSwitch. And suppose I want to establish a connection between the end user to the office. So for the first time, the flow tables, that's a table that stores routes in suites. They are empty. So for the first time, when I start a package, when I start a flow coming from end user to the office, this flow is going to be redirected to controller, and then controller is going to calculate the route, the best route, and then it's going to write in the suites that are implied in the path where is the route using the OpenFlow controller, the OpenFlow protocol. So to implement an SDN, we have, as I said before, we have frameworks that are written in Python. We have Ryu, it's a Python controller. Then we have Mininet, that's also a Python controller that we can prototype our network and our topology. And using SDN, and when I'm able to program my network, I'm able also to create virtualized network functions. So before I had, for example, I had to, if I want to have a firewall solution, or if I want to have load balancing, I had to go to a specific company and maybe buy their solution. But with NFV, I have the power to program my own network functions. So as we are using controller that knows all the topology, and I have APIs that abstract the inner details of the network, I'm able also to create services, network services like NAT, like a DNS, or like load balance, and so on. And it's becoming very, very used, mainly by the telecommunication companies. And just to summarize here, we have a Mininet that we can prototype our network that's written in Python. Ryu, That's an SDN controller written in Python. And we have OpenVSwitch, that's a virtual switch implemented in C. And just a reminder, we have Opendaylight, that's an effort of the network community to create a standard in networks. Because today we have, for example, HP has its own controller, Cisco has its own controller, Nicira has its own controller. So that's the same problem we have today. Each vendor implements its own solution, and we need to have a standard. So companies like Cisco, HP, Avaya, and many others start a project that's called Opendaylight. Actually, it's a consortium in order to create a standard for network applications, to build network applications. So Opendaylight, it's a huge umbrella, and behind of it, we have a controller project, we have a BGP project, we have, have a lot of network stuff that you could adapt your need, and you could go to Opendaylight. And actually, the company where I work, we say that we are pure Opendaylight, because sometimes there are companies that get the project from Opendaylight and create some its own version of it and sell it. So we are truly open source, and we work only with Opendaylight, and we are able to customize based on your use case. So we have more than 40 projects under the Opendaylight umbrella. So I'm pretty sure your company will not use 40 projects to implement a use case, because it doesn't make sense. So we are expert, and we are able to identify the piece of Opendaylight that is going to be usable to your use case. So I'm going to demonstrate how we do it. So the first thing I'd like to show you is my demonstration. You can clone my repo. I'm using Vagrant to spin up some virtual machines and to clone Ryu and Mininet stuff. And you just need to have an hypervisor and Vagrant. Are you familiar with Vagrant? Okay. So very quickly, what I have here is a Ruby file that describes my virtual machine. And you just need to clone my repo, install these two stuff, and Vagrant up, and we're gonna have a new VM. So I have here Hue. Hue is the SDN controller that I've mentioned before. And I'm going to start here. I'm going to show you first Mininet. And here. So all projects are open source and are available in on GitHub. And I'm going to start a topology here. Can you guys see over there? Here? Okay, sudo mn controller remote topo 3 def 3. What does it mean? It means that I want to create a network topology based on a tree-based network topology with a depth of 3 levels. So the first error we get here is, as you can see, it's unable to contact the remote controller. So because I still don't have a controller, I'm going to start here a controller. I'm going to stop. What I typed here was start the Ryu controller and observe the links that's going to be created using Mininet. and I'm going to create a Mininet, a network topology. So I'm going to test here a pingo stuff. Okay. And I have here a network topology based on the topology that I specified using Mininet. So here, if I click on each switch, here I'm able to see the OpenFlow message, the OpenFlow protocol message behind the switch. And as I'm able, once again, as I'm able to see every single point of my network, I'm able to handle all of them and to be able to write a custom topology or make or be able to create a different scenario based on my use case. We can use the Mininet API. So the Mininet API here we have in the GitHub repository, we have a lot of examples here, and just one very quick and easy. It's the Linux router, for example. So what I have here, it's so small. It's better? Yeah. So I have here some the Mininet API that abstracts switches, hosts, and routers, and we are able to, for example, here I have a host number 1, and I'm able to set the IP, and I'm able to set the default route, and here I have the run, and I just need to topo equals network topo, and we get the network, the Mininet network here, and we start, and we have our topology. So the code behind that line that I've typed before, it's all this code. So, and I also have here, for example, I don't want a tree-based topology, and I want just a single one just to check some points. And we have here, oops. I just want one level of the tree, and you can come from here, come here, and you just have here one switch, for example. And also, just to finish, we are also able to connect through SS8 protocol all the hosts that I create here. So in this topology, I have one switch, and I have 2 links, because I have 2 hosts, H1 and H2, and I'm also able to perform some network stuff like, for example, iPerf server and iPerf client, and I'm able to test this kind of stuff. Like, and here I create a server to listen to TCP packets. So just to finish, and I have just 30 seconds, and actually, the guys are using SDN solutions, and thank you for being here. And with SDN stuff, we can go forward in the network stuff, and we can just using Ryu and Mininets, the pretty basic stuff, and you can create some proof of concepts before to implement in production. And we still have a lot of work to do, and I invite you guys to join the Opendaylight community. That's it.
All right, thank you, Icaro, for the presentation. If anyone has any questions, feel free to come down and take the microphone.
Thank you. I have a better understanding of what SDN is, but what I still don't get is why would I want to use SDN?
Yeah, okay. So why your question is about why Google and Microsoft?
No, why would I want to use SDN? I am not Google or Microsoft. I just work for a small company with a couple dozen servers.
Okay, flexibility. You are able to deal with network details programmatically. Even for small business, it's interesting. Actually, we could apply it to big data centers. But this flexibility, you can create a proof of concept before to really spend your money, buying network solutions and network appliances. And we are not using SDN. We will not be stick with only one vendor, because sometimes the networks industry, they like to sell you all the solution. And for example, if you need a load balancer and it has its own solution, and we cannot, actually you can, but it's hard to use HP solutions, Cisco solutions, so the vendor locking problem. So even if we're not so big, it's interesting to have this flexibility and this independency.
Any other questions? All right, well, thanks again, Icaro, for the presentation.
Thanks.